Okay, hi everybody. Today we were looking, or yesterday, we were looking at setting up the idea of hypothesis testing. Today we're going to look at actually doing an example. So the first example we're going to look at is the Cobra Cheese Company example. So that was where people were getting milk from suppliers to make cheese and they thought water might be added. So they found, or they took a sample of 25 samples of milk from a particular producer, found their mean freezing temperature was negative 0.541, and for normal milk it's 0.545 with a standard deviation of 0.008. So the null hypothesis is the hypothesis of no difference. So that's that mu is actually equal to 545, so this milk is actually the same as whatever we would get from normal milk. And here the alternative hypothesis is that there is actually a difference, so it's not equal to 0.545. Now our test statistic is Z. So here we're not going to worry about using X bar, that's what they've used here, but we're going to just simply use Z here. So for Z, the Z value is Z equals X bar. Take mu, so this is how we convert our score, our X bar score, so our mean from a sample of 25 to a Z score. So it's sigma divided by the square root of n. And then we have to put in our values for that. So our values are negative 0.541 take, and our mean, because we're basing this on the null distribution, our mean is going to be negative 0.545. And then sigma is 0.008 and n is 25, and so when we work that out we get a Z score of 2.5. Now the null distribution is the distribution used, unsurprisingly, to test the null hypothesis. So it's a distribution which we use to find the probability of a value being at least extreme, so at or more extreme than this score here, so this X bar score here. Now in this case we've converted it to a Z score, so the distribution is going to be Z, which is normally distributed with a mean of 0 and a standard deviation of 1. Now in Hazy, he puts it as X bar is normally distributed with a mean of whatever and a standard deviation of whatever. Now that's not actually right, because we're using the test statistic Z, then the distribution used to test the null hypothesis is going to be this distribution here, the Z distribution. Now if H0 is true, so if our mean is negative 0.545, then that means that the probability of getting a value which is at least as extreme as the X bar we found is equal to the probability of Z being greater than or equal to 2.5 plus the probability of Z being less than or equal to negative 2.5. So this idea of at least or more extreme than the X bar we found. Apologies, sorry. And so when we work out that probability, we find that that's equal to 2 times the probability of Z being greater than or equal to 2.5. And I've already done it on the calculator to find that it's 0.0124, so that's equal to 0.0124, which is less than 0.05. And so what that tells us is that we have to, or we're going to reject H0 at the 5% level. So the reason we do that is because our p-value is the probability that a random sample mean is at least as extreme as the observed value. So what we're basically saying is, well, if our null hypothesis is true and there's no difference, then the probability of getting such an X-bar score from a random sample of 25 is around about 1%. It has a 1% probability, and because that's less than 5%, we're going to reject the null hypothesis. So by rejecting H0, we reject the notion of no difference. So we have statistical evidence that mu is not likely to be negative 0.545 because there's such a low probability here. That's our statistical evidence for milk from this supplier, and so that means they may be adding water to the milk they are supplying. So what that really means is that, or what you need to note about this is, we're not absolutely categorical. So we can't say they are, but we say it's this mean is not likely, so they may be adding water to the milk. So note the sort of softer tones, if you want to put it that way, that they talk about this. Can't be absolutely categorical, but that we can say that we reject H0 and they could be adding water. So we think of X bar as an estimate for our mean of this milk, so for mu. So what that means is the observed value of X bar equal to negative 0.541 differs from the null value of mu naught, which is equal to negative 0.545. So that's, yeah, I mean, if X bar is an estimate of mu, it's not a very good one because it differs. Though it's not too far away, but in terms of this standard deviation, that is quite a long way away. So there's a couple of possible explanations for why it's different. So it could be that our null hypothesis is true, so our mean is actually equal to negative 0.545, and X bar differs from the X bar differs from the null value due to sampling variability, which is a nice way of saying, well, perhaps this sample was just a more extreme case, and so in this case we just got, it turned out that we sort of got this 1% probability actually happening, and so for this sample it just differed from the mean because it was just that particular sample that was sort of more different than others. Or it could be, and this is key, that H0 is not true and x bar is therefore estimating some other value of mu. So that's other than negative 0.545. So that means that our null hypothesis may not actually be true. So the mean of milk from this producer may not have the freezing temperature, or the mean freezing temperature of 0.545, and so it's actually got a different temperature, mean temperature, because they're adding water, and so x bar is sort of trying to tell us that, hang on, I'm estimating some other value of mu. So the purpose of hypothesis testing is to help decide between these two explanations. So that's where we do this idea of rejecting the null hypothesis or accepting the null hypothesis. So if it's greater than 0.05, we do not reject. So we don't actually accept, but we do not reject the null hypothesis. And if it's less than 0.05, then we reject the null hypothesis. Okay. So we have another example, but I'm going to go through that in the next video. But just before I do that, these are calculator instructions. So what I'm going to do is I'm going to show you how to use the calculator to do a hypothesis test. So if I just go back to where you're used to, go back to stat, and then we go to, and so then we go test. So F3 is test, then F1 gives us a Z test. A T test is something you don't do, that's for uni, so leave that until you get to university. And then it's F1 again for 1S. Now we have variable up here, that's what we want. Often you may just find it already set to the list, so make sure you press F2 for variable. Now mu is not equal to mu naught. You can do mu is equal to greater than or less than mu naught, but in this case we're not going to do that, so we want mu is not equal to mu naught. So that's what we're testing. Mu naught, well, mu naught is the null hypothesis, so that's what it would be if the milk from the producer was normal, so negative 0.545. Our standard deviation we found in the question, if we go back to it, up here it's 0.008. So I've entered that, and then at x bar we can read straight off is negative 0.541, and we took a sample of 25. So I'm going to go execute, and we're going to find that our p-value is 0.0124. Now in the next example I'm going to show you how much writing I would expect you to do to answer a question where you use your calculator.